partying back home, and that's it, just those two. Right, so what we're going to look at in this lesson is how to calculate uncertainty. So I don't have Microsoft, I use LibreOffice, so I'll open up the calc program, which is like Excel. So what we'll do is, first is we'll just make up some data to practice with. What we're going to do is what you will need to do for your Newton experiment when you type the report. So we'll make, how many data points did you have? You did, but you did each one twice, right? Yes. So it's like you have 20 then. Yes. Yeah, so we'll go with 16 as an example, okay? So this is the idea. You have data for x and y. X could be force and y could be acceleration, whatever. And you plot them. And because you did each one twice, you'll have 2 points which are close together each time. Really, they should be the same, but of course, because of uncertainty, they're not. And what type of relationship should we have here? We should have a straight line, but again, in real life, we won't quite have a straight line because of the error. So let's make up some data points here. X and y. Let's just go with 0, 1.1, I don't know. You can use the same numbers, please. 2, 2.99, 3, 4.1, 5.2, 6.05, 6.98, 8, 9, 10. 1. It's confusing me. I need to make up good numbers, please. Here, I'll shrink this down a bit. What?
Is there something after the...
No, that's the last one.
So we have 12,
Huh?
12 points.
Yeah, doesn't really matter. I just need enough for an example. Okay, do we have this typed up? Can I continue? Good. As in, I can continue? That's good, question mark. What's wrong, Omar? You're just typing numbers. How could this have gone wrong? Wrong. What went wrong?
Then just retype it.
Yeah? No, we just insert a new...
And then you have to change the y.
Step 1. Let's calculate the uncertainty for the x. Now remember, we have 4 ways to calculate it. Number 1, we just look at the instrument. Number 2, what was it? It was the minimum minus the maximum divided by 2, wasn't it? That was it, wasn't it? No, there was something else, wasn't there?
The smallest measurement.
Yeah, half the smallest measurement. And then fourthly was using the formula. Do you remember what the formula was? Oh, no. I'm sure you wrote it down. Does anyone remember it?
Adding or subtracting or...
No.
The big reading
No.
minus
That is part of that section. Does anyone remember the fourth way to calculate uncertainty?
Average.
Yeah, right? Average what?
Average of the average.
Oh, close.
Average,
The average difference.
between the two different 2 points we got.
No, he's closer. It's the average the average of the difference between the data and the average. So, what should I do here with step 1?
and the average.
Find the average. Okay, so I'll write the average. Now, I'd like you to do the same so we can all stay together. I'll just put the average on the bottom. Oh my goodness, there's so much heat coming out of this projector. I'm going to die.
Don't.
That's not going to help, dude.
We'll move the hot air away. Or wear a t-shirt. Take
Or...
off your shirt!
OMG. Right, I'll put the average down the bottom. I would like you to skip a line so we don't mix it up with the data. Okay? So what you do is you type in equals in the box. Too hot. There we go. You type in equals average bracket, and then you highlight all the x's. Don't highlight the x itself, and then close the bracket. So this is what you have typed into the box: average A2 to A13. And we should all get the same average. Yeah? Then what you do is you copy and you paste into the next cell. Yeah? Got that? Yeah. No. Got that? Yeah. Okay. No, anyways, I'm just going to delete that now because I just wanted you to practice getting the average. Okay, but we're going to do something different now. So for most experiments, we can do it this way, and I'll just want to show you it this way, but for Newton and other experiments like it, we have another advanced way, a fifth way of calculating the uncertainty. But I just want to practice this way first. So, the next thing to do is calculate the difference. So here you write equals absolute, which is ABS, bracket, and then here I type A2 minus, and if I scroll down, my average is on A15. Now, we don't type A15. You might say, well, why not? Because we need to tell Excel that the average is a constant that's not changing. You see, A2 does change. Can you see? It has all different numbers. But what doesn't change is the average. So the way we tell Excel that it's a constant is we use the dollar sign. So we type $A, $15 and close. Alright.
Can just highlight from plus F4 was it?
Oh.
So I can't see.
What's wrong, Andrew?
I just can't see.
Then move. Why did you sit there anyways? There's a plug right there, and there's two over there. And there's 2 over there. There's 1, 2, 3, 4, 5 empty plugs on the back wall. Now, come on, Andrew, you know better than that. Now, I realise that means you have to sit a bit closer to these 3 guys, but, you know, life is full of sacrifices. Okay, do you have that?
Yes.
Did you get this number? Yes? Then what you do,
Down.
yeah, you grab the corner. I'll wait till you pass it. Guys, grab the corner and pull it down. And then it carries the formula down. Then, what you can do is copy this and put it here. Yeah?
Copy away.
Just the average box to the next one. Yeah.
Did you click on a seesaw?
Which one?
Just anyone, I just need to form
Well, probably the first one would be the best one. Is that okay, guys? Now, this is using formula method 4 to calculate the uncertainty. But there's a small problem here. This isn't really the uncertainty, because part of the reason, are you listening, guys? Part of the reason these values are different is not because of error, but because we are changing the values because we want to have different measurements. So the uncertainty is not really as bad as 2.67 units. Part of the reason this is so big is because it thinks these should all be the same, but they're not. They should all be different because that's how we designed the experiment. So we need another way to calculate uncertainty in experiments where we have an x and a y and we're trying to make a line on the graph. Okay, so how do we do that? So if I go back to my picture here, what we're going to look at is not the average difference between the data and the average, but the average difference between the data and the line. So we're going to look at this distance, this, the average distance between the data and the line on the x. And we'll do the same thing on the y as well. In fact, let's start with the y first. So before we can do this, we need to find this line. And what's really nice is Excel can calculate the m and the c for us. So I'll undo. And here I'll write m. And here I'll write c. So the formula to calculate m, you'll be pleased to know, is simply just slope. And then you highlight, now please be careful, for me and probably for you, you highlight the y's first, and I have to press comma, you may have to press semicolon or something different, and then you highlight the x's. And then we close. And Excel has given us the m now. So the slope of the line is this. Have a guess at what the function is to calculate the c.
Intercept.
You are correct. Intercept, and what do we highlight first? The y's, comma, and then we highlight the x's. Close. And now I have the c. Got that, dudes? Yeah? Okay. So now let's go back to this here. It's okay, Andrew? Yeah. So let's just pick a point here. Let me just make it nice and clear. Let me put a point here, and we call this point, let's just say x1, y1, one of our data points. and here's where it should be on the line, should be here. So this is the difference, and I'll call that difference E for error. So how do we calculate the error? Well, that would be the y value on the line minus the y value from the data, the difference between the two. This is equal to mx data plus c minus y from the data. Now, if you think about it, we do know the m, we know our x obviously, it's in the data, we know our c, and we know our y in the data. The only thing is, I don't care if it's plus or minus, so I'll put an absolute here. So the formula is mx plus c minus y. That gives me the error here. Is that okay or is that confusing? It's okay? Is it? Yes? So, let's look at this here. What?
What was your value for the C?
I'm going to zoom out so we can try and see everything at once. A little more.
Here, okay.
Yeah. Right, so watch carefully. First, I'll put in equals. Oh, well, the very first thing I'll give this a title. So this is. Now, there is a name for this. It's not quite called error. There's a special word that describes this length of the difference between the data and the lines. I don't think anyone would know it. It's called residual. So I'll just write or residual y, res y. Alright, so the formula is equals ABS for absolute, with the bracket. Okay so far? And then M. Now please be careful, because M is a constant, so what do we need to put with it? The dollar sign. So it's $16 times X. And where's the X here? What cell is the X in? What one? A2. Plus dollar B $16 minus Y. Yes? And the Y is B2 and close the absolute. So, do we want this number to be big or small?
Small.
We want it to be small, and let's see what we get. We get a small enough number. And we'll copy this down. Can you see it if I click it? Okay, let me just click it. Yeah, just give it a second now.
Wake up.
I think part of the reason the laptop is slow is because the hard drive is encrypted. I encrypted the hard drive. So it means every time I log in, it has to, as you can see here with Dropbox, resynchronize the files.
What do you have on that? That's your encrypted the hard drive.
All government secrets and the likes.
Behind Wikileaks?
That's it, yeah. This is where I take off my mask. Ah! It was me all along. Okay, do you have that there? Now we have to do the same thing, but this time for the x. So we want, let's imagine we have our data point here. We now want to look at the horizontal difference, the horizontal residual. So it's nearly the same thing, except we don't use this formula. We need to rewrite this so x is the subject. So we get y minus c equals mx. So then x equals 1 over my plus minus c over m. Do you see what's happened? I've just rewritten it so the x is the subject. So then to get the residual this time, it will be absolute x for the line minus x for the data, which in this case will be absolute 1 over m y for the data, minus c over m minus x for the data. That gives me the horizontal residual. Okay, can I continue then? So to make our lives a little bit easier, what I'll do is underneath, I'll put here 1 over m. A little bit tricksy. 1 over m, and then underneath that 1 over m, and underneath that 1 over this number, 1 over A16, and I get that. And then the second one is minus c over m, and that's equal to minus c divided by m. So I get this number. Can I put this on full screen to make it a little bit clearer? Let's see. No. Oh, I do.
Minus c over
It's trying to change it.
Yeah.
If you type an apostrophe before you type the minus c over m, it forces Excel not to do anything to it. So if you type apostrophe minus c over m,
wow.
I know things you can't even imagine. Horrible, horrible things. Okay, can I continue? Yeah. So this is equal to
But now it's not a minus.
apostrophe. Oh, hang on. Here, you mean this box or this box?
No, the answer is not a minus. It's not minus 0.
What did you get?
0.4.
Did you have minus in the formula?
Yeah, that's what the... Yeah, apostrophe minus the...
Wait, no. Which one has the apostrophe? This one or this one?
Oh,
But this one doesn't have an apostrophe.
yeah.
Show me it.
I know that.
Yeah, but the 100 is what I care about. Click the 100. There's no minus in that formula, dude.
Oh,
Come on, you're making yourself look bad.
no.
Right. Continue. So here equals absolute $18 times what did I say, x or y in my formula? I forget. Y this time, which is B2 plus $$18 minus A2. and close.
There's a problem with this one.
OMG, is there? Now, do you not remember what happened 60 seconds ago?
There's something else. Yeah, I know.
It worked? What number did you get? Small number?
Yes, pretty small.
This number?
Yeah, we're going to be 20.
It's the first thing.
I don't want to. One moment while it responds. There you go.
Is that a plus or minus before the 18?
The heck? That is a minus. You mean here, is it? That's a minus. Wow, you just said 0.1000.
But that's 9. Oh, it's okay.
Okay, continue. Children, continue. What's that? I don't understand.
Yeah.
Okay. Scrolling down. Can you do that too? And then underneath we'll calculate the mean average residual for x. Whoops.
No equal.
No, I'm just giving it a title. Wait, the first one was x, wasn't it? No, the first one was y. And then the next one is average residual x. And here this is average of those, and then this one here is average of those. And these two numbers are really important for what's happening next, so I'll put them in font here. Did you get those two calculated? Right. So next now, when you have this graph here, each point is not perfect. So what you can imagine is on Monday you do the experiment and you get your points and you get your line and you calculate the slope. Then on Tuesday you do the experiment again. You get nearly the same points, but not exactly the same, and you do the experiment again, and you get a slightly different line. And then on Wednesday, slightly different. And then on Thursday, slightly different. And then on Friday, slightly different. So the slope, m, it also has an uncertainty to it. And we would like to calculate the uncertainty to it. So the formula for calculating the uncertainty of the slope, it's the average residual y over average residual x divided by square root n, where n is how many pairs of points you have. So here, what I'll do is I'll just do the y over the x. So that's equal to this one divided by this one. Yes? And then here, I'll do this divided by square root. And how many data points do I have? How many pairs do I have? 12. Yep. So I end up here with 0.565.
Is it plus or minus, or divided by the square root?
Yeah, 12.
What was the 16? The one on the left?
Oh, just the y divided by x residuals. This one over this one. C16 over D16. Okay,
Can I see the formula again?
which one? This one?
Yeah.
Yeah. Continue. Continue. Yeah. Now, you might think, well, that's everything we need. No, because if you think about Newton's experiment, it's not the, well, you needed the slope, but it's not the slope that gave us the mass, but 1 over the slope. So you might say, oh, okay, so no problem. So then the uncertainty of the mass is then 1 over the uncertainty of the slope. No, because you have special formulas for calculating uncertainties. Do you remember, for example, when we had, if we want the uncertainty of something like, let's say, a power n times b power n, do you remember this? Let's call that z equals that. The uncertainty of the z over z was equal to square root n, the uncertainty of a over a squared, plus n, or I suppose this could be m, uncertainty of b over b squared. So if you have the formula mass equals 1 over slope, then that's equal to slope minus 1. So that means the uncertainty in the mass over the mass will equal square root minus 1 times the slope over the uncertainty in the slope. No, that's upside down, I'm sorry. The uncertainty in the slope over the slope squared. And there's nothing else to add to it because there's just one thing in the formula. But then when you look at this, you realize, okay, well, this is just going to be square root uncertainty in the slope squared over the slope squared. But what happens here? They cancel. So you can go cancel, cancel, cancel. So you end up with the formula, the uncertainty in the mass is equal to the mass times the uncertainty in the slope over the slope. Now I'll just have to wait for my pen to catch up. Any minute now.
How would
There we
this
go.
make us any better engineers?
Hold on. For goodness sake. Now. Okay. So, do we know the uncertainty in the slope? Yes, that's what we literally just finished calculating. That's, if I go back here, the whatever, what was it, what was the last number you just made? When you 0.56. Okay, that's the uncertainty in the slope. So, we know that. Do we know the slope? Yes. Yes. Do we know the mass? Well, we do, because remember we're saying that the mass is equal to 1 over the slope. That was the whole key idea here. So the uncertainty in the mass is equal to 1 over the slope times the uncertainty in the slope of the slope. So all of this we know. So finally we can get the uncertainty in the mass. So for example here, our final answer would be bracket 1 over the slope, which is this number, times the uncertainty in the slope, which is this number, over the slope, which is this number. Can I press enter? Can I press enter? Yeah? 0.147. So this means at the end of the experiment you could say, according to Newton's second law, the mass should be blah 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 plus or minus 0.147. What is wrong, so this is exactly the type of maths you do in first year engineering lab work. You know likey? Why not?
You don't have to think, just do the formula. It's like, you have to memorize the formula.
In university, you will have to take a class on why these formulas are why they are and why they work. This is quite beyond the scope of this course. You'll just have to trust me on it. Show a bit of trust. Yeah.
No.
Okay. To what?
To the
In your chemistry lab report, did you need to make a scatter plot of x and y for anything? Nothing.
Not for the titration. I did a graph for the distillation of coffee.
Let me just put it to you like this. In chemistry, did you ever need to use the slope of a graph for some kind of estimation of something?
No.
No? Okay. More of a physics thing, I guess. Now, the very last thing I want to show you, which will be really quick, which I've probably shown you before, is the scatter plot. Can I go do that now? So, what we do, we'll highlight the x and the y, for me anyways, and insert chart, although it might be a little bit different for you. Are you all using LibreOffice?
Of course not.
Just don't appreciate the importance of open software. We pick scatter. Next. Now please listen carefully, because you will lose marks needlessly if you don't listen carefully. I do not want a legend on the graph. It is totally inappropriate. Get rid of that. Secondly, I want the x and y axis lines displayed. I want a title, a good title, and if you like you can put in some subtitle. The x-axis needs to have an x name with x units and use a / between the name and the units, and the y-axis needs a y name with y units, whatever the units in the name are, and then finish. And then also, if you pick insert trend line, so this is the line, and you can choose to show the equation on the line. You don't have to, but I like it. And this other thing here, coefficient of determination, which I'll explain what it is now. You can click that. We get this. Now, I hope those numbers seem familiar, don't they? They were the M and the C. Does anyone know what this R squared of 0.977 is? Has anyone seen that before?
Is it the residue of x?
No, funny enough, different meaning for this or. I'll tell you then. This is a way to quantify how good the line fits the data. So, if the line and the data perfectly fit, it's a 1. And I mean perfectly fit, everything is on the line, then you get R squared equals 1, which is perfect. If it's just a random mess, then you can probably guess R squared equals 0. Okay? So, Indeed, indeed. So, in my opinion, anything greater than 0.9 is for physics, you want this to be nearly 1, because in physics you have, unlike other science subjects, the chance to have very accurate values. So in physics, we really want this to be nearly 1. In a subject like biology, those losers can probably get something like a 0.5 fit, and then the losiest losers of them all, say some kind of social science, they are usually happy with an R squared of 0.2. You really, I know, what losers, huh? So R squared nearly 1 is what you are trying to get. There's no way you can change it. It just reflects how good you did the experiment. But, of course, it's not like I'll mark you down if you have an R squared of like 0.9, but what I will mark you down on is if you do not try to explain why maybe you have a bad fit in your report. Do you understand? Yes. Okay, so let's just briefly recap the situation. You have now seen everything you need to see for the physics coursework 2. We discussed the uncertainty, the errors, the requirements, how the marks are allocated, and how to calculate uncertainty. So you can start the physics coursework 2 officially, but I'll make the official start Friday, and then 2 weeks after the holiday it's due. In the maths class later today, I hope to have enough done so that you could then, if you wanted to, start the maths assignment. Possibly. It's not going to be that bad. It's going to be worse. So I'll see you later then.
Just this question.
Yeah.
The graph.
Yes. This one.
Yes, how
Yes.
do you get all the thingies to adjust and edit?
Oh, how to change them afterwards?
No, now.
Get what thingies?
The one where you started to write the X and the Y and the units and the title and the knowledge and...
Yeah,
Yeah, insert.
chart.
Yes.
Now you're using Excel.
Yes.
So I don't know, because I think in Excel you have a little option up here to pick chart properties or something.
Highlight your data. No, good thing. You don't need the table.
Yeah. Chart, this one, scatter.
You need to highlight the numbers. Highlight the data. No, that's the excellent one.
Come on in, we're finished.
Insert. Scatter.
No, they had one look of us and said.
Yeah, it comes up بعدين.
And then